subscribe and press this bell icon to never miss another lecture video. Hi, welcome to GATE ESE lecture. We are in lecture number 16 of signals and system. Now this is your second module, that is discrete time signals, and here we are going to discuss another very conceptual question from the subject sampling. Okay, now here look, okay, let me solve this question, and after that is a very conceptual question. Through this question I'm going to revise all the concept of sampling, and after this question there are a couple of informations that I need to share with you. Now let's start with this question. It is saying ki we are having an analog signal XAT, which is nothing but 10 cos 100 pi t, and if the sampling frequency is 75 Hz, sampling frequency is 75 Hz, sampling frequency fs is 75 Hz, find the discrete time signal xn, find the discrete time signal xn, and also an alias frequency corresponding to the above sampling rate. Listen to this: alias frequency corresponding to this sampling rate, okay, this is the simple thing that it is asking for. And now let me break it for you one by one. Your XAT is given this, so XA in TS will be nothing but 10 cos 100 pi NTS. Clear? This is your one bar bracket. Now here, look here carefully. What is this 100 pi is actually? Okay, now I'll get back to this. What is this 100 is actually? 100 is the frequency corresponding to this analog signal. It is saying कि find the frequency of analog signal which is alias to this analog signal. Okay, so that is what it is asking for. Now let's first find out the x of n value. Okay, what will be the x of n value? Now I can write it down: 10 cos 100 pi n by fs. Correct? N by fs. Now this n by fs I can convert it to like what? It can be also be written 10 cos 100 pi by fs value is given 75 into n. Clear? Now this can also be written as 10 cos 100 by 75. It will be 4 by 3, I think. 4 by 3 pi n. Clear this concept? We just cancelled it out. Now what we got here? We got x of n. Look here carefully. We got x of n here. Clear? Now 4 pi by 3, it seems very difficult. No, look, 4 into 180 by 3, it will be around 240 degree, you know. It's a kind of difficult thing. So let's subtract it like minus 360. 2 pi cos is always a period of 2 pi, no? So 360 into 240 degree, that will come out to be something around 40 plus 40, around 80 degree, I think. Yes or no? No, sorry. 240 0 2 1 120 degree. So this can also be written as x of n equals to 10 cos 2 pi minus 4 by 3 pi into n, which will be nothing but 10 cos 120 degree means 6 pi minus 4 pi by 3, and this will give you around 2 pi by 3, right? 2 pi by 3 into n. So this is what your x of n is. So your x of n that you got is 10 cos 2 pi by 3. Right, that is your 120 degree. Yeah. So 2 pi by 3 into n. So this is what your value of x of n. Now it is asking ki find the time signal x of n. Sir, I got the time signal, I got the discrete time signal x of n, that is given as 10 cos 2 pi by 3 into n. Now it is saying find the alias frequency corresponding to the above sampling rate. Now the signal which will be alias to this, listen to this carefully, this is very important. यहाँ पे थोड़ा सा turning point है. The signal which is alias to this x of n, that will be definitely in terms of like that has to be situated like after 2 pi distance. You understand? That means that function will be x of n. Okay, let me write it down in white. X of n equals to 10 cos 2 pi by 3. Listen to this. 2 pi by 3 plus 2 pi into n. That has to be situated plus 2 pi distance, in plus 2 pi distance. You got this idea? You got this idea? This is a very, very, very core idea. That means it is saying, so this function, that means this function is, this signal is alias to x of n. Now this is x dash n, huh? This x dash n. So this signal is alias to this x of n. Clear? Now what will be this value will come out to be 2 pi by 3 plus 2 pi, that will be 3 into 2 6 plus 2 pi 8 pi by 3. Now I can write down 8 pi by 3 into n. Now it can be said that this 8 pi by 3, it is alias to this function. Now I can write down this 8 pi by 3 by 2 pi into 4 by 3 into n. I can write down like this. Simple. Okay, now listen to this carefully. Now what I need to find out, I got the signal which is alias to this x of n. Now I need to find out the analog frequency which is associated with this signal. So what is this signal? Let me copy paste कर लेते हैं एक बार. Look here, it is saying keep find the analog frequency to this signal. Now what is the analog? So this is in the format of x dash of NTS. ये वही फॉर्मेट में है ना. into NTS. If you relate it with this term, so that means you will get 10 cos 2 pi fa by fs into n x dash NTS. Now look, if you this is what you got the answer. This is what is the standard form. Yes or no? Standard form. Now what you need to do, you need to find out this fa value. You need to find out this fa value. So 2 pi 4 by 3 into is equals to 2 pi fa by fs. Clear? And fs is given. fs is कितना है? 75 hertz है sir. 75 hertz. So we can find out. So 2 pi will be cancel out. So fa equals to, look here, fa equals to 4 by 3 into 75. Okay, there will be 100 hertz. Clear? So 100 hertz is the analog frequency for the signal that is alias with which signal? With 10 cos 100 pi t. Okay, our original signal, our original signal. So clear? With this we are done with this sampling concept. We'll again come back to this, all of this analysis once we are done with the Fourier series and Fourier transform concept. उसके बाद हम will going to have detailed discussion on the bandwidth, the sync function. इतने काफ़ी beautiful questions, like ISRO के लिए important questions, BAR के लिए important questions. There are a lot of interview related very core concepts we're going to discuss, and we're going to start from here. Okay, सो उसके लिए मैं सैम्पलिंग वाले सब्जेक्ट को छोड़ रहा हूँ अभी. आई एम नॉट गोइंग टू एग्जैजरेट दिस थिंग. सो देर आर कपल ऑफ बेसिक थिंग्स दैट आई नीडेड टू टेल यू. आई थॉट आई शुड टेल यू टू एट दिस पॉइंट ऑफ टाइम. तो ये सारे बेसिक आइडियाज़ है. विल अगेन कम बैक टू दिस थिंग्स. नाउ लेट्स गेट इन टू द डिस्क्रीट टाइम सिग्नल्स के स्टैंडर्ड सिग्नल्स और उसकी सारी चीज़. हम वो लोग वहाँ पे उस दुनिया में चलते हैं. वहाँ के स्टैंडर्ड सिग्नल्स, उसके भी एनर्जी पावर सिग्नल्स होंगे ना, उसके भी इम्पल्स होंगे, उसके भी यूनिट स्टेप फंक्शंस होंगे. देर आर लॉट ऑफ beautiful concepts on discrete time signals. So let's get into that, and in the next video lecture we'll start analyzing all this discrete time signals. And keep watching JL, subscribe to our channel, do share with your friends. Okay, see you in the next video lecture of discrete time signals. Till then, bye.